We've already solved simple inequalities. Now we're going to solve compound inequalities, which is basically just like having two simple inequalities and one problem. So here's one way you might see them. They're always going to be and or. Now if you see them all lined up like this, that's and. That means everything that we say at the end has to be true. But this one's kind of simple. You could solve this in one step. Even though it looks weird, all I need to do is solve for x. So I have negative 2 times x, which means I need to divide by negative 2. As long as I do that to everything, this is going to work. Now I have to be careful I'm dividing by a negative, so my inequalities need to flip. So negative 6 divided by negative 2 is 3. This inequality flips. Negative 2 divided by negative 2 is gone, leaving me with an x. This inequality flips, and 12 divided by negative 2 is negative 6. Now a lot of the time you'll see it written from least to greatest, so they may flip it around, but either of these is correct. What this means is x has to be in between negative 6 and 3. Both of these things have to be true. Now for an or, it's just like in English class, one or the other has to be true. I still just have two inequalities separated by an or, and I'm just going to solve them both separate just like we would have yesterday. So I'm going to subtract 1 from both sides on this one. So 5m is greater than 30. And I'm going to divide by 5. So m is greater than 6. Over here I'm going to subtract 12. So 5m is less than or equal to negative 3 minus 12 is negative 15. Divide by 5. And m is less than or equal to negative 3. So one or the other of these things has to be true. Either m has to be less than or equal to negative 3, or m has to be greater than 6. It can't be in between. Last one. Let's see. This is kind of like before, except instead of being one inequality, it has an and, which means both inequalities have to be true at the same time. So let's start, and get a clean piece of paper. This may take a little bit of work. Let's start with the inequality at the top. So negative 7 plus 10x excuse me, is greater than or equal to 8x minus 11. Now first, I need all my x's on one side, all my numbers on the other. So I'm going to subtract 8x from both sides. So that's negative 7 plus 2x is greater than or equal to, that's gone, negative 11. I'm going to add 7. So 2x is greater than or equal to negative 4. I'm going to divide by 2. Since I'm dividing by a positive, I'm going to leave the inequality alone. It's greater than or equal to negative 2. So there's one side of my answer. Now let's solve this one. So 8 plus 14x is greater than 15x minus 3. This time I'm going to subtract 14x from both sides. So 8 is greater than x minus 3. And then we're going to add 3. So 11 is greater than x. So you could write it like this with an and in between. Usually if it's an and, we're going to write it as one big inequality, just like that first example. So you always go least to greatest. So negative 2 is less than or equal to x, because I flipped this around, which is less than 11. That's usually how you'll see it written.